we look at Pythagoras theorem, we know that a squared plus b squared equals c squared, and it's formed with a right triangle. And when we draw the hypotenuse square here, the two sides have parallel sides here, and these two sides are perpendicular to the original side. So we have 90-degree angles that are formed to make this square. And the way we make this diagonal square is we actually use the right triangle in here. And we can see that the right triangles in here are the same as that white right triangle. Okay, and that right triangle in here allows us also to calculate the slopes of these line segments. Okay, we can use that right triangle to calculate the slopes of the line segments. So we can calculate the slopes of the two sets of parallel sides. And so I'm going to do these ones in red. And I'm going to use this slope triangle here. And I can see that the slope of this line, the change in y over the change in x, okay, that's going to be, I'm going to count 1, 2, 3, 4, 5. So it's going to be, looks like it's going down. So going down 5. And then the change in x is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like it's 12. So it's going to go over plus 12. So that's the slope of these two sides here. And then let's compare that to the slope of the perpendicular sides here. So these green lines, okay, we can use the same triangle. Well, we're using the same triangle. These are exactly the same triangle, but the slope of the perpendicular sides are going to be almost the same. But what's happening to this red triangle compared to the green one? Well, we've got this long side horizontal. Now we have the long side vertical. And so basically the horizontal length is becoming the vertical length, and the vertical length here, 5, is becoming the horizontal length. So we just basically switching the x and y. Now we have to be careful because there's some negative going on in there, and it looks like it's becoming a positive slope here. So I'm just going to do this. I'm going to change the x and y, but I'm going to make one of the terms negative, and that makes this negative divided by negative into 12 over 5. So this green line has a slope of positive 12 over 5. And if we flip the fraction and make it negative, we end up with the slope of these two lines here, which are 90 degrees or perpendicular to the green lines. And we can see that the switching of x and y does make sense, because if we look at this triangle that calculates the slope here, and the red triangle that calculates the slope here, we can see that the horizontal and vertical components switch. That means the rise and run should switch. But that's not the only thing that's happening. We're going from negative slope to positive slope, or vice versa. So we should always change the slope to the opposite sign. So basically, when we talk about perpendicular lines, the perpendicular slope is calculated by the negative reciprocal. Okay, reciprocal means to flip the fraction. So if I have a slope of a over b, okay, a over b, the perpendicular slope becomes b over a, and then we have the negative. Okay, so just make sure that you understand we're using the negative reciprocal. Okay, the perpendicular slope flips the fraction and also uses the negative, or going the opposite direction. So going up, it goes down. Okay, or instead of going down, it goes up. And these are mutually perpendicular to each other.